and 2 over solving systems of equations by graphing day 2. The only main difference from yesterday on notes 10.1 and today 10.2 is we're going to refresh how to graph in the calculator, and we're going to talk you through the steps of finding the solutions using the calculator. So make sure that is close to you. Pause the video if you need to grab one. So number 1, they tell us that buying gas by the gallon plus a drink varies based on the store you go to. Use the tables below to determine the cost of the drink and the rate of gas for store 1 and store 2. After how many gallons does the gas cost the same at both stores? And then they want us to go ahead and they've asked us to label the X and Y axis. That's already there for us because our X is in the first column, gallons goes on the bottom, and then because cost is in the next column, cost goes up here. So in order to write a system for the situation above, what I'm going to do is use stat edit. So I'm going to click stat and then enter. I'm going to enter my numbers on the left and the right sides. So this is for the first station. If you need to pause to catch up, now's the time. But I click stat, scroll to calc, option 4, enter, enter, enter. So my first equation is going to be y equals 1.5x plus 4. Remember, 1.5 is the same thing as 3 over 2. You can do 1.5, math, enter, enter, to turn that into a fraction. So when we graph, we can either use these points or we can use this equation. So I can use the point 0, 4, 1, 5.5, 2, 7, 3, 8.5, or I can use the start at 4, go up 3, right 2. So that would be up 1, 2, 3, right 2. We just won't have as many points in between. Sorry, that's my dog getting water. And this is station 1. So for station 2, we're going to do the same type thing. So stat edit, replacing these. The gallons stay the same. The cost is what changes. So remember, you can type over it or you can scroll up so the L2 is highlighted and click clear, either way. So stat calc 4. So y equals 1x plus 6. And I can graph those again. 1, 7, 2, 8, 3, 9. So this would be station 2. So part C asks us, after how many gallons does the gas cost the same amount? Now remember, we talked yesterday, when you're looking at tables, you are looking for where your X's and Y's, what point is exactly the same. So if you notice, here 0 is 4, well here it's 6. 1 is 5.5, here it's 7. 7 and 8, 8.5 and 9. So it is not any of these that we can see, which is why we had to graph it. If you look at this point right here, which is the point 410, that is where my lines cross. That is if you were to continue the table where 4 gallons will cost $10 no matter which station you go to. So 4 gallons is the answer they are looking for because it says after how many gallons. So 4 is where the gas would cost the same amount. So if you need 4 gallons of gas and you're getting the same drink at both stores, it wouldn't matter which one you went to. Anything less than that, you would want to go to the pink station because it's cheaper. Anything more than that, you would want to go to purple because it's cheaper. But if you're going 4 exactly, or you need exactly 4 gallons of gas, it would not matter which one you go to. Number 2 asks us, what is the solution to the system of equations below? Now, I know you're grabbing for that calculator, but before we do, let's see if we can visually find it. Remember, we are looking for a point that is shared on both tables. So on this left side, I have -3, 0. I don't have that point over here. Here I have 0, 1. Here 0 is -4. On the left side, I have 3, 2. On the right side, I have 3, 2. Oh, look at that. So the point 3, 2 is going to be the solution because it is on both tables. The same point exists on both tables. Now, are you wrong if you put this into stat edit, this into stat edit, get 2 equations, and do what we did on number 1? No, it's just going to take you a lot more time. Hopefully you can see number 1 took us a lot more time. Number 2 is a lot faster. So if you have a table, whether it's x's and 2 sets of y's or multiple tables, make sure you're looking first for those points before you try to do anything else. So these steps right here are what we are going to use to do the exact same thing we did yesterday, but make the calculator do the work for us. So what we're going to do is make sure they are ready to graph. They're in y equals. We're going to input them in the calculator using y equals. We've done this before, but some of us only ever put one equation in at a time, so this time we're going to do 2. Then remember, we're trying to find the intersection or the point where they cross. So we're going to click second, trace 5, enter, 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 and the calculator will do that work for us. Watch this. So solve each system by graphing, sketch the graph. Anytime you see a grid, or a lack of a grid, I should say, that looks like this means they want a sketch. This means we want you to do it in your calculator, but we want to see what you're looking at in the calculator. Now, just to make sure you are aware, this is what you had yesterday, which is a true grid, which means graph by hand. But today, when you have blank or kind of naked graphs or grids, we are wanting just a sketch that you're seeing in the calculator. So for number 3, this first equation is not ready to be graphed because remember, we're going to go to y equals, which means we need y equals, not 4x plus y equals. So we move 4x to the other side, it changes signs, x and 3 are not like terms, so we rewrite. Now that y is by itself, I'm ready to go to y. So in y equals, I'm going to type negative 4x, remember the x is by the alpha, plus 3. For the second one, we have a table. So in order to do this with the table, I'm going to go back to stat edit again, because this time I do need an equation. So stat, scroll to calc, option 4. And our equation from the table is y equals 3x minus 4. Now remember, these pop out as y equals, so that's what I'm going to put in y2. So if you notice, I am putting both of these equations in y1 and y2. Now mine is a little bit nicer calculator than what some of you might be using, so mine are going to show up as 2 different colors. Yours may not, and that's okay. So when I click graph, this is what I can see, cross, cross. So on my sketch over here, and it does not have to be color-coded, I'm going to do a cross and then a cross. Okay, now does this look perfect? No, but does it give me or does it help my teacher really see a brief idea of what I'm seeing in the calculator? Yes. Obviously, if I walk over to your paper and you're looking at something like this, I know we have an issue because that's not at all what our graph looks like. So to find the solution, this is steps 3 through 5 up at the top. So we are going to click second, trace. Notice above that is what is in blue and it says calculate. We want the calculator to calculate something for us. We are interested in the intersection where these lines cross. So I go to 5 and then I click enter, enter, enter. This down here needs to say intersection. If it says first curve, second curve, or guess, you have not clicked enter enough. It must say intersection. So my solution, x is 1, y is -1. Remember, we write them as points just like we did yesterday. I can see from this graph that it's crossing, so I write my 1 solution where it crosses. So we're going to do the same thing for number 4. For f of x, I have x minus 3y equals 6. Over here, they're wanting you to get y by itself. So we're going to do that right here. We're going to move x to the other side. Remember, negative x and 6 are not like terms. And then I divide everything by a -3. So I get -1 divided by -3, which is 1/3, x minus 2. Then for the other equation, I'm going to move x divide. So I get 1/3 x plus 1. Now, some of you might remember we did something kind of similar to this yesterday, but just to make sure we know these steps, I'm going to type in 1/3 x minus 2 and 1/3 x plus 1. Oops, sorry. When I click graph, I can see what's happening, and some of you might have seen this coming, and that's great. If not, no worries, you can see it in your graph. Ooh, obviously not an artist, but you get the idea. This is kind of what I'm seeing on my grid, not exactly, but pretty close. So I'm looking at these lines, I'm looking at these slopes, I'm noticing my equations are not the same, but their slopes are the same because these lines are parallel. Because these lines are parallel, my solution is no solution or none, because these lines will never ever cross, so I cannot find an intersection. If you didn't catch that, you could click second, trace, 5, enter, and it'll tell you the calculations. There's an error, there's no sign change, there's nothing, lots of notifications here, because there's not going to be an intersection. Okay, so the last one, number 5, we're looking at special cases, so this one's a little bit more on our own. So x plus 9 equals 3. Now, in order to graph this, I need to get that letter by itself. Now, this one only has one letter, so I'm just going to solve for x. So my first equation is going to be x equals -6. Now, this is a special case. I'm going to go to -6 on the x. Again, this is a sketch. You can't type x equals into your calculator because you only have a y equals. However, if you struggle with which way they go, you can type in y equals -6 to remind yourself what the y looks like. The y goes side to side. Well, this is an x, so it needs to be going the other direction. So if you are still struggling with those special cases, you can use this. This is not what I'm graphing, but this reminds me that the y's go this way, but I need an x, so I need to go that way. The second equation says a line perpendicular to the y-axis and goes to the point -2, 5. So for -2, 5, I go to the left a little and up a little. Okay, these aren't exact, that's why it's a sketch. Perpendicular to the y-axis. Perpendicular means opposite of y. So if this is y, it's not going to look like y, which means it's going to go through y. So that's going to go through y at the y from my point. Now this one I can check. If I say y equals 5 on my graph, does it go through the point -2, 5? So second table, -2, 5 is there because all of those y's should be 5. Okay, so I can check that one on the calculator. Now my solution is still where these lines cross. And this one is going to be the x and the y from my equation, because equation 1 says all of your x's are -6 and equation 2 says all of your y's are 5, which means my solution has to be that x and that y. There's no way those could change. So for your exit ticket, they are asking you to match the description to the correct linear system, graph, or table. So I'm going to start with the graphs first because I think they're a little bit easier. This one crosses right here. It looks like we go 1, 2, down 1. So that would be 2, -1, which would be number 3. B looks like it's going down 1. So that would be the point 0, -1. And then E, these lines are parallel, so there's no solution. So 2, which says I do not have a solution, would be what I'm looking for. Now with these tables, remember with the tables, I am looking for where are my y values the same. So 2, -3, -3 means 2, -3 is going to be my solution. However, if I look at -1, those are the same, and those are the same, and those are the same, and those are the same. So what's happening is instead of 2, -3 being my solution, all of these are solutions, okay? Now we have a word or a set of words for a lot of solutions, which is infinitely many. So obviously by process of elimination, when I look at D, this is the only one that has those y values. So -1, 2 is going to be my one and only solution for that problem.